Assalamualaikum dan selamat datang. Okay, today will be the last topic regarding this one. Is actually not a programming of PLC, but is how we convert when we have a schematic circuit to a prepared circuit for PLC. That's the purpose of this topic. Convert relay schematic to a schematic used for programming PLC. Okay, before that, okay, this is example. We are trying to convert relay schematic from this diagram to a PLC, programmable logic control. Okay, actually what are the example? Example here we have two inlet pipe. This one you have solenoid valve A, solenoid valve B, and then when this two is open, what happen? Then the two liquid coming in, and also fill in this tank. So when the tank is full, this sensors switch sensor. This ball will go up and switch off the. Okay, sorry, before that, FS is float switch. Switch sensor, float switch. Float because it has a ball over here that go up when the water rise. So this ball go up until touch that one, and what happened? It will start. It will stop the liquid from entering. A shut off, B also shut off. Then this motor start operate. Then we'll mix. Between A and B. After 1 minute of steering, then C, valve C will open and let all the mixture flow out. And the things continue until one button is pushed. That means stop everything. Right? So okay, basically this is what should be done. Done by this graph, by this picture. So start button press when the A and B energized, and these two permit liquid to begin to fill in the tank. So the liquid will be filled in the tank. When tank is filled, the float switch strips. So we have no. So the float switch strips this energized solenoid. This energized A, solenoid A and B, and this de-energized. De-energized. Float A and B, and start to set motor to mix the liquid to mix it together. So motor one motor will start and the liquid will be mixed. The motor permitted to run for 1 minute, so you have timer relay. After 1 minute, the motor will turn off, and solenoid C energize to drain the tank. So you will empty the tank after it's already mixed. Maybe this one is I don't know, syrups, and this one will be sugar, liquid of sugar. So you make everything and then go flow out. Example, and then a stop button can be used to stop the process at any point. So here it doesn't show stop button, it should be somewhere else. Stop button. If the motor become overloaded, the entire action will be circuit will be stopped. So here mention that overloaded means you have overload sensor. The motor should have overload sensor, and when the motor is too over the loads, and then they will stop operates. Once the circuit has been energized, it will continue until it is manually stopped. So here means that when we have a push start stop button, perhaps when just press one time, so this thing will continue running until we push it back the button and will stop. So let's have a look on the relay, on the circuit, relay schematic. So okay, this is a relay schematic. Here we have a push button over here. Okay, and we have a push button over there. This is to start, and this may be to stop. Okay, and will stop. So here, for example, we have a CR1. Okay? CR1 is contactor, contactor CR1. This is coil, CR contactor, coil relay, coil relay, coil relay. Okay? This one is coil relay contactor 1. This coil relay contactor 2, coil relay contactor 3, coil relay contactor 4. Okay, coil relay or relay coil. Alright. What happened when we push this start button? The current will start move, and this coil relay coil will energize, and what happened? This one will send signal towards the other coil relay contactor. From normally open will become close. From normally open will become close. So when de-energize, normally open become close. D1 will have current, D1 will have current, this one also will have a current. Okay, sampai till that. Okay, and then at the same time, this one also will have a current. Okay, so because this is push start stop button, maybe this have a spring that one time push, then it go up. So then what happened? The current is still going because we have a contactor relay over here. So when this contactor relay still have a current, so this is still energized. This is still the current will keep on moving until we push this one, manually stop button. Okay. Okay. Let's say we go to line number 2. Line number 2. This is when you have a current over here. So it's connected. So what happened? This one is also connected. Okay, because it's not full. The float switch does not reach the level it needs. Okay, so it still have a current. So this one also have a current. So solenoid valve A and B function. So this one will be operate. Okay, A and B operate, and then leave out the water and also the sugar into the tank. Okay, until this float sensor reach the level, I mean this one also reach the level. Okay, this thing float sensor will go up, and then what happened? This is normally closed, become open. That means this one will not A and B will not have any power. So it will cut off. Okay, and then line number 3. Line number 2 will have a current because at the same time this one is still functioning. So you still have current over there. So current moving, this one become close, move, and this is still close and will operate the motor. So the motor will turn this wheel over here and steer whatever you have inside the tank. Okay, at the same time, this is time relay. Time relay start functioning. You set it to 1 minute perhaps. Okay, so after 1 minute, it will energize. Okay, after 1 minute it will energize. It's not directly energized like the other coil. This is also coil perhaps. After 1 minute it energize. So when it energize, what happen? It will send signal towards this time relay. Number 1, time relay number 2, contactor, time relay number 3. From normally open become close, from normally close become open. So what happened? This one will be open. This one will be open. And this one will be closed. Okay, after 1 minute. So this one open mean this is safety actually. So make sure that motor solenoid valve 1 and 2 still not moving. Okay, and then it will send signal to the, because this is still have electric because of this one, still energized. So electric move, and solenoid valve C is having current and energized, mean there will be a flow of mixture fluid. Okay? So everything is coming out. Everything is coming out until this float sensor is going down. Okay, until the float sensor is going down. Okay, what happened when the float sensor going down? When the float sensor is going down, means that release back all the dots, all the contact one. So what happened is going down means that this line number 3, 1, 2, 3 will not have any current. So this time relay will not have any current, means that all the connector back to original. This open, this is also closed, this is also closed, and then solenoid valve 1 and 2 will function and fill up the tank again until this button is pushed. Okay, what is the purpose we understand this? Because we need to know how many are input device and how many are output device before we put it in the PLC. PLC adalah one of the controller. Okay, beside PLC, as another video shown is for example Arduino Uno, the one that I show is Arduino Gen 2, Galileo Gen 2. So this is a microcontroller. Okay, you should know which one is input and which one is output. So here the circuit, by understand that, then we develop a circuit that connect 4 input and 4 output device. And have a look what is 4 input and 4 output device. Okay, this is an example of controller that has I/O input output of 32. Okay, as you can see, number 1, 2, 3, 4, and then we have a common 5, 8, 7, 8, 9, 8, and then we have common 10 until 12, common 3 until 16, and common this is all input. So you could put any input device, either or, tak kisah which one, tapi here you put everything at 1, 2, 3, 4, 5, C common. And here is output device. Output we have from 17 up to 30 to then we have common at the window So basically okay, how you want to know whether this is input or not? So just by looking at the relay schematic before this. Okay, for example, here we know that the switch the start stop button, push button, and normally close or normally open switch, all are inputs, because we have to push it. We have to push. This is input button. So this switch 1, switch 2, input button, and we have also overload contactor. This is also input, and we also have a float sensor, float switch, also input. Will give signal, and this is give signal, and we have output. What is output? Output that means the thing that done the task. The end, the end, not sensor, the end actuator, the end machine that done the task. For example, here we have solenoid valve, solenoid valve A, solenoid valve B, and solenoid valve C, and also motor to mix or stir the liquid. And this is actually normal. This is hot. Normal means it go to the ground. Hot means this is positive, positive. Okay, I think that's all for me. Okay, for this PLC. So that's all. Thank you.